I am going to give an introduction to the cloud computing now. What is cloud computing? First question, why we have to use cloud computing? Let us see. Case 1. Write a file, save it, computer is down, file is lost. But files are always stored in cloud, never lost. That is why we are using clouds. Now case 2, use IE, download, install and use QQ, download, install and use C++, download, install and use, get the serve from the cloud. What is cloud and cloud computing? Cloud. Demand resources or services over internet scale and reliability of a data center is called cloud. What is cloud and cloud computing? Cloud, I already told you now. Cloud computing is a style of computing in which dynamically scalable and often visualized resources are provided as a serve over the internet. Users need not have the knowledge of expertise in or control over the technology infrastructure in the cloud that supports them. The architecture of the clouds. The architecture of the clouds, it contains, the cloud is somewhat, it is linked with the Google and Salesforce, Microsoft, Amazon, Yahoo, etc. like that. So this is the architecture of a cloud. And what are the characteristics of cloud computing? Virtual, software, databases, web servers, operating systems, storage and networking as virtual servers. On demand, add and subtract processors, memory, network bandwidth and storage. What are the type of cloud service? Cloud service contains basically three things: SaaS, PaaS, IaaS. SaaS, SaaS, that means software as a service. PaaS, PaaS, platform as a service. IaaS, IaaS, infrastructure as a service. So all these things you get in the form of a service. So that is cloud service. Software delivery model, let us see. Under the software delivery model, no hardware or software to manage is necessary. Service delivered through a browser. Customers use the service on demand. Instant scalability is possible. Examples. Your current CRM package is not managing the load, or you simply don't want to host in-house. Use a SaaS provider, that is service as a platform, such as Salesforce.com. Your email is hosted on Exchange server in your office and it is very slow. Outsource this using hosted Exchange. Now, platform delivery model. The platforms are built upon infrastructure which is very expensive. Estimating demand is not a science. Platform management is not a fun. So examples. You need to host a large file, say 5 MB, on your website and make it available for 35,000 users for only for 2 months duration. Use CloudFront from Amazon. You want to start storage services on your network for a large number of files and you do not have the storage capacity, use Amazon S3. So like this, cloud services are always possible and you do not spend for the platform, you need not spend for the service, you need not spend for any software like that. Next, let us talk about the computer infrastructure delivery model. A platform virtualization environment. Computing resources such as storing and processing capacity is possible. Virtualization taken up as a further step. Examples. You want to run a batch job but you don't have the infrastructure necessary to run it in a timely manner, use Amazon EC2. You want to host a website but only for few days, use FlexiScale. So like that, for every activity in cloud, you have service. So you are not investing anything on the infrastructure, you are not spending anything on the service, you are not spending anything on the software. So you are simply giving a metered fee, that I am going to come later, a metered fee for the services what you are using in the cloud. Now let us talk about the grid computing. Good old times, grid computing was very popular, solving large problems with parallel computing and made mainstream by Globalist Alliance. And utility computing. Let us talk about utility computing, offering computing resources as a metered service, introduced in late 1990s. Then software as a service, network-based subscriptions to applications, and gained momentum in 2001. So cloud computing, next generation internet computing, next generation data centers, these are currently existing now. So this is the milestone how the cloud computing has come now. And industry transformed now. Today, the cloud computing is mostly widely available and totally it becomes industry transformed applications now. Grid computing and cloud computing, let us talk. And what is the share a lot of common points, grid computing and cloud computing. Say intention, architecture and technology. These are all shareable between these two things. What is the difference? Programming model, business model, computer model, applications and virtualization. Next, the problems are mostly the same. Manage large facilities. Define methods by which consumers discover, request and use resources provided by the central facilities. Implement the often highly parallel computations that execute on these resources. Virtualization. Let us talk about the virtualization. Under grid, what is happening? Do not rely on virtualization as such as clouds do. Each individual organization maintain full control on these resources, whereas in the cloud, an indispensable ingredient for almost every cloud is available. Google Application Engine is a cloud platform. It does one thing well. Google Application Engine, it does one thing well, running web applications, simple application configuration, scalable, and it is very secure also. Application Engine does one thing well, it continues, namely Application Engine handles HTTPS request, nothing else. Think RPC, request in, processing and response out. R means request, P means processing and C means responses out. Works well for the web and AJAX also for other services. Application configuration is dead simple, no performance tuning is needed in the case of Application Engine. Application Engine architecture is also very simple, and you can have a look at the figure in any of the books under cloud on the cloud computing. You find that Application Engine architecture will be very simple. How to use Google Application Engine? Download Java 6, download Eclipse and Google plugin, register a user account in Google, create an application like Python or Java and upload the code. Study Google applications, and I am giving a website http://code.google.com/intl/en/ app engine /docs /java /getting started / you can make use of it, and thereby you can master Google application engine, and thereby you can pick up certain cloud application services, and you go, if you start doing it, and it's a very autonomous learning, you can pick up very easily.